In the last problem, we just found one real zero of the polynomial function 2x cubed minus x squared plus 2x minus 3. And you may be asking yourself, well, how many zeros do we have? How many zeros does this function have? Well, we found one. How many more zeros should this second part have? If you recognize that as a quadratic equation that you can use the quadratic formula on, then you would know that you should be able to get two solutions of that second part. What do you notice about the leading term in this polynomial? You'll notice that it is an x cubed, and this function can have up to 3 zeros. If you were to sketch a cube function, you'd say, well, a cube function could do something like that, and that would give up to 3 real zeros. There are some other options. A cube function might just go like that, and you'll say, well, there are 1, 2 real zeros. But if you remember in the section about multiplicity, this 0 would have a multiplicity of 2. That 0 would have a multiplicity of 1. So we're still adding up to 3 there. Our last case would be something like this, an x cubed that only crosses the x-axis once. In this case, we see one real zero, but that's it. And we're going to have to wait till section 4.6 to see what's going on with that one. In general, if you ask the question of how many real zeros, the answer is up to the degree of the polynomial. But a better answer is Descartes' rule of signs. Descartes' rule of signs that says that the number of positive real zeros can be found by looking at the number of sign changes in our function. So let's take this example function, f of x equals 3x to the 7 plus a bunch of other stuff, and look and see how many sign changes we can see. The 3 is a positive, and what we're looking for is the change of the sign of the coefficients. So this first one changes from positive to negative, that's one sign change. From negative to positive, that's a second sign change. It remains positive there. From positive to negative, that's a sign change, and then it remains negative. So you count these, 1, 2, 3 sign changes. What that means for us is that there are 3 positive real zeros. That's not exactly true. There's an or here. Or, anytime that I have 2 or more for this number, I have to reduce that by 2, which we'll see where that 2 comes from next section. So if I reduce 3 by 2, I get 1. So, or there could be 1 real positive 0. What about negative real zeros? In order to find negative zeros, we replace all of the x's with negative x's. Notice what happens when we do this. All of the odd powers, all of the coefficients in front of the odd powers have sign changes. So up top we had a positive here on that 7, now we have a negative. We had a positive in front of that x cubed, now we have a negative. And the negative x up here becomes a positive x down here. The even exponents don't have any sign changes there. So we're going to look for the sign changes. We go from from negative to negative to negative. That's all one. So the first change is right there to positive, and then the next change is right there to negative. So what that tells me is there are two negative real zeros. Or, since this is 2 or more, I reduce that by 2, there could be 0 negative real zeros. If we'd like, we can summarize our results in a table just by taking each combination of result that I found. So I could have 3 positive real zeros, or 2 negative real zeros. I could have 3 positive real zeros and 0 negative zeros. I could have 1 with a 2 or 1 with 0. Now, we said that this should add up to 7, right? Well, something that could happen is we could have complex zeros. We'll talk more about that in section 6. But if there are any leftover values, there's a possibility that 3 plus 2 is 5. If I had 2 more, that would add up to 7. Here, if I have 3 and 0 and 4, that would add up to 7. 1 and a 3, oh, sorry, 1 and a 2 add up to 3. 4 more would add up to 7. And 1 and 6 would add up to 7. So there's a possibility of complex zeros as well. This gives us a little bit of an idea of where we should start looking when we think about trying to find zeros. We know for a fact that there are going to be some positive real zeros, but we're not sure whether or not there are any negative real zeros. So if I were going to start looking for some real zeros, I would probably start looking with the positive numbers.